Okay, so we're starting this next section here by taking a look at these triangles right here. So this one, this one, this one, and this one. And if you look at those triangles, you might, how are they related? They all work for the Pythagorean theorem. If I plug it into, I will get 3 squared plus 4 squared is equal to 5 squared. 6 squared plus 8 squared is equal to 10 squared. But what they are is, they're all multiples of this one right here, 3, 4, 5. So this one is by a factor of 2, this one is by a factor of 3, this one's by a factor of a half. And so this is an example of what we call a family of right triangles. In this case, it's the 3, 4, 5 family, or it's also known as a Pythagorean triple. There are a number of triples that are useful to know, and in particular, you should memorize. And so, for example, 3, 4, 5 is a common family. 5, 12, 13 is a common family. 7, 24, 25, which we've encountered in some of the previous worksheets, some of the previous videos. 7, 24, 25 is a common family. 9, 40, 41, and then 8, 15, 17. All 5 of these are very useful to know for this class, as well as for the SAT, ACT. It's basically a shortcut to help you on problems that have to do with the Pythagorean theorem. Now, to memorize some of these things, to remember these, one way I do it is, if you look at this right here, 3, 4, 5, 5, 12, 13, 9, 40, 41, 7, 24, 25. If I take the first number and I ask you, how is that first number related to the second 2? So this number right here related to 4 and 5. Well, if I take 3 and square it, can you see that's equal to 4 plus 5? And if I take the 5 and square it, it's going to be equal to 25. 12 plus 13 is 25. 9 and square it, 40 and 41 is 81. 7 and square it, 49. 24 plus 25 is 49. You can do that with any odd number for the first, like the smallest number in the triple. So for example, 11, if I look at 11 squared, it's going to be 121, so it's going to be 60 and 61. And that would be another triple. There's an infinite number of these triples. Just take an odd number to start, and then you can square it, and then find the 2 numbers that add up to that number that are next to each other, and that's going to be your triple. So really, that'll hopefully help you if you forget some of the triples. I would recommend writing these triples down at the top of any quiz or test that we have to do with these. 8, 15, 17, obviously you're just going to have to memorize on your own. Okay, related to this is something called the principle of the reduced triangle. So the idea is this: if I have a right triangle, and I have a side that's like 1,000, let's go 10,000, and then this side is 30,000, and we're trying to find x. I could always put this in the Pythagorean theorem, do 10,000 squared, 30,000 plus 30,000 squared equals x squared. Or what I can do is, I can reduce this triangle down by dividing it all down by 10,000. And so I'm going to end up with a triangle that's a 1, 3, x triangle. And now I can, easily do this. 1 squared plus 3 squared equals x squared. Or in this case, x is going to end up being equal to the square root of 9, or no, square root of 10. And then what I do, since I know that this is the square root of 10, I just need to, in order to get it back to this over here, multiply it by 10,000. So this will be 10,000 times the square root of 10. And that is the idea of the principle of the reduced triangle. Okay, so let's try this problem down at the bottom here. These are all right triangles. So this is right angle. So this is going to be in 15, 17. Hopefully you can see that this is an 8, 15, 17 triangle. And then this is a 6, 8. Well, I can plug it into Pythagorean theorem, but hopefully you can recognize that 6, 8 is part of the 3, 4, 5 family of right triangles by a factor of 2. So it's just going to be 5 times 2, or 10. And so now this is going to be a right angle right here. So it's going to be a 10, let's call this y, 10 squared plus y squared equals 26 squared. But if you can recognize that this is a 5, 12, 13 right triangle, then this is going to be just the 12, or this y will be 24 right here. Okay, because it's by a factor of 2. This is multiplied by a factor of 2. This is multiplied by a factor of 2. 12 is multiplied by a factor of 2. So that's going to be 24. And then this final one here is going to be a right angle here. It's something x 24, 25. So this is just going to be 7, 24, 25. So here we are on the back side. We're going to have a bunch of triangles that look like this. And what you have to do is find the missing side. So if I have, for letter A, for example, here, 21 and 35, I'm not sure what triple that is, what family that belongs to. So what I'm going to do is I'm going to divide it by the largest factor I can divide it by. So in this case, that would be 7. So this is going to be 3, and this is going to be 5. And hopefully you can see that that's a 3, 4, 5 family. So this side would be the 4 side. But because we multiplied or divided everything by 7, I'm going to need to multiply this 4 by 7. So this side's actually going to be 28. Same thing with the letter B here. So 45 and 51, not sure what family that belongs to, but if I divide everything by a common factor, let's divide it by 3. So this is 15, this is 17. Well, now I see that this is an 8, 15, 17 triangle, where this side is the 8. And so, but I need to multiply back up by 3, so this is going to be 24 on that side. The next one is 15, 36. Looks like I can have in common a 3. So this is going to be a 5, and this is going to be a 12. And that'll be a 5, 12, 13 triangle, but I need to multiply this by 3 to get it back up. So this is going to be 39. Let's look at this. Keep doing some of these problems. 48, 50. I can divide these by 2. And so this is going to be 24 and 25. And then, so this is going to be a 7, 24, 25. Multiply that by 2. So this is going to be 14. 15, 20. Hopefully you can see that this is just a 3, 4, 5 triangle. This is 3, 4, 5. Divided by 5, multiplied by 5. So this is 25. This one here, divided by 2, 8, 15, 17, multiply it back by 2, so it's 34. Okay, this one is an interesting one because this 2.5, anytime you see something like a half or some sort of fraction or a decimal, try to multiply it by something to make it so that it is no longer a decimal. So I'm going to multiply this by 2, so it's a 5. Multiply this by 2, so it's a 12, so that means it's a 13. But since I multiplied everything by 2, now I need to divide it by 2. So 13 halves would be the answer there. Let's jump down to this one here, J. So if I look at J here, hopefully you can see it's a 6, 8, and then it just becomes, if I wanted to, I could divide this by root 5, divided by root 5, and get 6, 8, 10, and then I need to multiply that by root 5, so it's 10 root 5. And then for letter K, multiply these by 10, so it's a 5 something 13, so it's going to be 12, divided by 10, so it's 1.2. 1.2. Okay, let's try this one last problem down at the bottom here. It's one of these type of problems where the person is walking north 12, 10 west, 2 south, and then 14 west. How far is she from her original position? So here's her original position. You want to find this direct distance. How far is that distance? So what I'm going to do here is I'm going to break this down into a right triangle like this. Okay, so this length here is just going to be 12 minus this 2 here. So 12 minus the 2, so it's going to be 10. And this side right here, down at the bottom, is going to be 14 plus 10, or 24. And so you're going to end up with a 10, 24 something triangle, or if I divide it by 2, it's going to be 5, 12, 13. So this one has to be multiplied back by 2, so it's going to be 26. So this distance is 26. Okay, so hopefully you'll find Pythagorean triples to be useful. I think you'll see it the rest of the school year in various places, and so don't be afraid to use that whenever you see one. Okay, good luck with it.